Hi, we'd like to go over the concept of volume, specifically for prisms and cylinders. There are other formulas for a pyramid or a cone. A volume is how much space is contained in a three-dimensional or 3D object. So we're going to be able to use the same formula. Volume is equal to capital BH, and we'll talk about what the capital B stands for. It's different than the lowercase b we normally use in math. And this is going to work for a cylinder, it's going to work for a rectangular prism, and it's going to work for other prisms, whether it's a triangular prism or even octagon, hexagon, and other shapes as well. But we won't get into those more complicated ones, but the same concept or same idea will work. So the first idea, or the first important thing, is to recognize what the base stands for in these shapes. So, but first let's talk about this capital B. When we talked about area, we talked about how to find the surface space in a couple of shapes. We did a circle, and we learned that the area is pi r squared. In a rectangle or square, we learned the area is lowercase b, so it's different than capital B. So the lowercase b we say is base times height. And we typically think of base on the bottom, but it's really not. It could be anywhere. The general rule is that the base and the height have to be perpendicular. And it'll be the same for these shapes in 3D as well. And the third one, we learned about a triangle. The area is 1/2 base times height, because it's really half of a rectangle or a parallelogram. So again, we noticed that the base and the height would be perpendicular, making a right angle. So we could call this the base, this the height. We can call this the base, and then this would be the height. Notice that their base and height are perpendicular, and the r, or the radius, would be used for the area formula. So how is the capital B different? It stands for area of the base, not base. So it's a little bit different meaning. You're going to have to find the area. But when I say base, it's important to understand the base is always going to be perpendicular to the height, just like an area. And for prisms, there will be two of them. So you notice down here we have a circle, that's the base. We could also use the one on top, either one. They're the same shape, and they're perpendicular to the height. Here would be the height. So again, if this is the height, then I see a base up here and down here. There are two of them. That's the rule. There are two of them in prisms. We only are going to find the area of one, and they are perpendicular to the height. So here we have a triangle, and over here a triangle, and again they're separated by the height. In this rectangle, we could change the base. We can actually, if we wanted to, make the base this one and this one, or the front and the back, and then the height would be how far apart they are in between. But we normally want to leave it so the top and the bottom are the bases, especially at the beginning, so we don't confuse you. So how am I going to apply this formula when I get to a volume problem? So let's say I wanted to find the volume of a cylinder. And let's say our radius is 5. So the first thing is to locate the base. It's the circle. I could use the top one or the bottom one. I'll use the top one. And I, in fact, like to draw it. Here's my base. We're going to find the area of it. That'll be our capital B. So again, our formula is area of the base times height. So if our base is a circle and the radius is 5, what we learned is the area of a circle, which you really need to know how to do before you could do volume. The area of a circle is pi r squared. So I simply put 5 squared pi, or 5 times 5 pi. pi. So my area of the highlighted part, the area of the base, is 25 pi. And then I plug in my height. And my height is 10. Notice the height is separating the two bases, and it's perpendicular to them. So when I put it all together, my volume is going to be 25 pi times 10, and that's going to give me 250 pi. So if we can find the area of a circle and recognize the base and height, we can find volume pretty easily. Here's another one. Let's see if you could do it. Pause the video, give yourself a moment. Maybe I'll make it face this way just to make it a little bit different. And let's say that the radius is 6. I'll give you a moment to pause, and when you're ready, unpause. So again, the bases would be the two circles. They're separated by the height, so the height would be 20. And I'm going to draw my base, the shape of it. And the radius is 6. So in order to find my my area of that base is pi r squared, or 6 squared times pi. And so my area of the base, capital B, is 36 pi. My height, we said, was 20. So we put them together for volume. And we get 720 pi. So let's take another look at another different prism. We'll use a rectangular prism next. So let's pretend that the bottom is a perfect square, and we'll make it 10 and 10. And we'll say that the top, the height, is 20. So if you didn't know that the 20 here that I just put was the height, we could decide which ones are the bases. I can color them in. These would be considered the two bases, and if those are considered the bases, then 20 would be the height. So we're going to pick one of the bases and find the area. And so the area of a square or rectangle, we learned, is length times width, or base times height, we often say. 10 times 10, which is 100. So our volume is going to be the area of the base, which is 100, times the height, or 2,000. Now, to be fair, we're only focusing on the math part. Since this is actually a unit of space, it's talking about how many little cubes would fit in here, little 3D cubes, and there would be 2,000 of them. We really want to say units cubed. So if it were inches, it would be inches cubed, and meters, it would be meters cubed. As we learn, area has units squared, volume will always be units cubed. So let's see if you can try one on your own. You can pause the video once we've drawn it. But this time I'm not going to make a square, I'll make a rectangle. So hopefully you paused it if you wanted to try, but if I want to consider the top and bottom the base, then 8 would be the height. It would be how far apart the two bases are. And it's perpendicular to them. So I'm going to draw my base and find the area of the base. So the dimensions are 10 and 12. So the area of a rectangle is to multiply 10 times 12. And that's 120. So my volume is 120 times 8, which is 960 units cubed. So we'll try one last type. We'll do a triangular prism. and we draw a triangle and sort of extend it back and draw a triangle that looks as parallel as we can. Let's make it a Pythagorean triple. So can you decide or figure out which one's the base that we need to find the area of? So a lot of people, they remember in younger years where we said base is the bottom, and they think the bottom here is the base. But remember, in prisms, there have to be two bases that are exactly the same, and it has to be separated by the height, which is perpendicular to them. So the two shapes that are the same are the triangles. That would be the base. And the height is how far apart they are, and it's perpendicular to them. So my height is going to be 10, and my base shape is a triangle. So I'm going to put all three numbers to see if you remember which ones we use. The area of a triangle is 1/2 base times height, lowercase b. The base shape is the triangle. When we find this area, that's what our capital B is, our area of the base. Remember, capital B is area of the base, not base. And base does not mean bottom anymore, not in geometry. So if you remember, the base and height have to make 90. So the 4 and the 3 are the two numbers we use. So 1/2, 4 times 3, which is 6. So the area of that base shape of a triangle is 6. So my total volume is going to be area of the base, 6, times the height, which is 60 units. Little cubes would fit in there. So hopefully that helped with how to find volume for prisms. And when we get into the other shapes, it'll actually help you to make a lot of sense. Like a pyramid or a cone is going to use something very similar, but it'll also use the capital B. So you'll understand it very quickly if you understand this volume of a prism. So just to review, the volume of a prism is capital B times H. Capital B stands for the area of the base. The base must have the same shape repeated twice, like the two circles of a cylinder. The height is what separates them, and it is perpendicular to the base. So even when we're using a rectangle or other shapes, the base must be the same thing twice. So we could use here the top and bottom, or left and right. I'm going to use the top and bottom. That's what we would consider the bases. We're going to get the area of one of them. And the height is the distance that separates the two of them. Don't forget, in order to find the area, we got to remember the area of a circle formula, the area of a rectangle or square, and the area of a triangle. And if you use other cylinders, like let's say a hexagon, you would use the area of a hexagon, whatever method you've learned, and follow the same exact steps. You'll get the area of the base. The base would be the prism shape, that's a hexagon. The polygon shape, that's a hexagon. And the height is going to be how far apart the hexagon on each end is. So hopefully that helps, and keep working. You all are great.